Okay, I got this oscillator all taken apart here. I really hate this design. I had to unsolder these transistor wires because these transistors they wouldn't pull away from this aluminum body here. They're like glued or epoxied in there pretty good. This stuff glue here is pretty hard, and I don't know if this stuff actually acts as a good heat transfer to this aluminum plate here. I kind of don't think so. It was just really a bear to take apart. I haven't checked the junctions yet to see if they're good, but this whole bottom piece section right here is solely for the temperature control. So we got a transistor there, a diode, some resistors, nice variable resistor, and then on the oscillator itself, see, we got a thermal fuse, which I think should have kicked out because this thing was really hot. And then we have a some type of thermistor there. I need to do a resistance check on that. Maybe that thing went out and this thing just ran away and kept on getting hotter and hotter. I don't know, but I mean they did achieve making this thing compact, but definitely not very serviceable friendly here. I don't know what this thing is right here. I'll have to look into that a little closer. You know what I think it is? I think it's a full wave bridge. And I have a sneaky suspicion that they were sending 110 volts AC to this. Of course, if they were doing that, then they would need a good sized capacitor, at least a small electrolytic somewhere on here, you would think, unless these disc capacitors are functioning that way. There's just capacitors all the way around there. I'm gonna read it with my own eyes here. They're 103s. They're 103s, whatever that. They're not very big. I don't think they would make good filtering capacitors, but then again, I don't really know. And they're on both the AC and the DC side. Hard to say. That would be a whole lot of ripple there. So maybe they use the AC for the temperature control part, and then the DC for the crystal oscillator. We got 4 wires here, and I think what they're doing, if you look at the schematic for this service monitor for this octal receptacle, you got a 20 volt pin that they're using to, I'm sure, just to power this crystal oscillator part. And then you got your ground, and then you have two outputs, and I'm pretty sure one is just for the sine wave, and the other is actually a TTL. We got a chip in here, and I looked it up. It's a F. It's a Fairchild, I believe, and it's a 9N72. I had to move that resistor over, /7472, and what that is basically, you could look it up online. It's basically a flip-flop. So we're getting both a sine wave and a TTL output here, and I got my probe on at least one of these coaxes here. I don't know which one that was, and I was probing around, and I probed this because I thought it was coax, but there's another one way back there. So one of them was for the sine wave, and the other was for a TTL. Anyway, I should have got something out of one of them, and I wasn't. So I'm thinking they're both important. I think, especially that TTL. So if this IC failed, and I'm not getting any TTL out of it, then this thing is just not going to work. It's not going to have that reference. So what I'm going to do here is I'm going to solder these wires, these four, back in here, and maybe I'll extend it. I think I'll solder some wires in here and extend it so that I can have some test points out here on the bench. Make it a lot easier. So get some voltage here. Actually, that red wire connects to that resistor, so that's one pin I won't have to worry about. And I went and desoldered that because I wasn't being smart. And I'll look to where those other wires go. On the schematic it says WT 5214 and 5215, and I think that's referring to the rear. There's a wire terminal somewhere on the rear of this panel, and I bet you it's going to a AC source there. I don't know, but I'm going to look into that a little deeper. But I'm not going to worry about the temperature control part right now. I'm just going to focus on this oscillator aisle, and I'm hoping that once I bring this to life, then that'll bring this service monitor to life. I've got a sneaky suspicion that this is the main problem. So I'll go from there, and then I'll make another video after I get this all wired up, and we'll put a scope on it, and we'll check for some pulses here.